Hello students, welcome to the class. So next topic is motion in a plane. So in motion in a plane, we will be discussing about what do you mean by a scalar quantity, what do you mean by a vector quantity. Then next, types of projectile motion. What do you mean by projectile? Projectile motion types. Example for that. Then equation of a trajectory. We will be showing how the equation of a trajectory forms a parabolic equation. Okay. So then next we will be discussing about some definitions like displacement of projectile, angular velocity, angular displacement. Right. So these all points we will be discussing in this chapter. Then next, mainly this chapter deals with the motion of a body in a plane. That is nothing but trajectory motion. The mainly trajectory motion we will be discussing. Okay. So here, what do you mean by motion in a plane? First, that we need to understand. Motion in a plane is the motion in two dimensions. For instance, projectile motion, circular motion, and so on. Okay. So projectile motion, that is motion in a plane, is nothing but what? That is if the motion takes place in two dimension, in the two dimension, for example circular motion, then projectile motion are example for what? That is motion in a plane. The reference to analyze a two dimensional motion will be the origin with two coordinate axes, that is x and y. Okay, the reference of to analyze a two dimensional motion, it will be the origin with two coordinates axes, that is x and y here, right? Then let us start with the first concept, that is projectile. What do you mean by projectile? What types of projectile motion? See here, what do you mean by projectile here? An object thrown into space after which it moves only under the influence of gravity, then that object is known as what? Projectile. So projectile is nothing but what? Here it is an object which is thrown in a space after which if it moves only under the influence of gravity, then that object is known as what? A projectile. So if you throw any object, then whatever the objects are there in a flight, we can say it as the objects are in a flight, that is called as what? Projectile. So in projectile we have three types of projectile. Okay, that is oblique projectile motion, horizontal projectile motion, then projectile motion on an inclined plane. These are the three types of what? Projectile motion here. Okay. So you can see the example for the projectile motion, the figure it is given. The first figure is what? It is oblique projectile motion. It is oblique projectile motion. Second one is horizontal projectile motion. Then the third one is projectile motion on an inclined plane. So by seeing the figure, you can clearly understand all the projectile motion and its types, right? Then next, oblique projectile. So what is oblique projectile here? The first figure explanation. In projectile motion, horizontal component of velocity, that is u cos theta, comma, acceleration and mechanical energy if it remains constant, while speed, velocity, vertical component of velocity, momentum, kinetic energy and potential energy, these all quantities changes. Velocity and kinetic energy are maximum at the point of projection, while minimum at highest point. While minimum at what? Highest point. So this is called as what? Oblique projectile. It is called as oblique projectile. So what do you mean by oblique projectile here? Here some quantities will vary, some quantities remains constant. That is velocity, acceleration, mechanical energy, it remains constant. And the other components like vertical component of velocity, speed, momentum, kinetic energy, potential energy will change. So such type of motion is called as what? Oblique motion. You can see the first figure that will give you the idea about oblique projectile. Next, equation of trajectory. So what is this? Before going to see the other definitions, let us see the equation of trajectory here. So equation of trajectory, it comes to one derivation here, right? So let us see that. So equation of trajectory, it is given by That is a projectile which is thrown with vertical velocity u cos theta at an angle of theta with the horizontal, the velocity u can be resolved into two rectangular components. So here what happens, that is whatever the projectile motion you are considering, if the object is moving with a initial velocity u, if the object is moving with initial velocity u, here what happens, that is if u is the velocity of the object, so here you can see this velocity u can be resolved into two components. One is u cos theta and another one is u sin theta. We can resolve it into two components here, u cos theta and u sin theta components. Then next, here theta is what? It is the angle for this motion. It is the angle with the horizontal axis, right? So we can write the equation as, that is given by here you can see the equation 1, that is for horizontal motion the equation becomes x is equal to u cos theta into t. This t can be written as what? T is equal to, it is x divided by u cos theta. It is x divided by u cos theta. And for vertical motion, y is equal to, it is u sin theta into t minus half gt square. Is for what? It is vertical motion. It is for vertical motion. Then from equation 1 and 2, if you see equation 1 and 2, what you can say here, from equation 1 and 2, we can write the equation for y is equal to, means substituting equation 1 in equation 2. That is the value of t in equation 2. That becomes u sin theta into bracket. T value is what? X divided by u cos theta minus half g into t square. T is what? It is x divided by u cos theta whole square. So substitute. Here u will get cancelled. X we are writing as it is. Sin theta divided by cos theta is tan theta minus 1 by 2 gx square divided by u square cos square theta is the equation for what? Equation for a trajectory. So if you see this equation is in the form of ax minus bx square. It is in the form of ax minus bx square. Okay, so which means that the ax minus bx square is what? It is the equation of a parabola. So what we can say, that the trajectory follows a parabolic path. It follows a parabolic path. You can see in the figure also. So if you observe the figure, it also looks like a parabola. So we can conclude that it follows a parabolic path. Is it clear? That is y is equal to ax minus bx square. Next, equation of oblique projectile also can be written as, so this equation can also be written as what? X tan theta into bracket 1 minus x divided by r, where r is equal to 2u sin theta divided by g. It is 2u sin theta divided by g is what? Horizontal range, r is equal to formula. So later we will see this same equation derivation in the later part of the PPT. Okay, so we have two equations here. One for oblique projectile, it is y is equal to x tan theta into bracket 1 minus x by r. Then we have another equation, that is y is equal to x tan theta minus 1 by 2 gx square divided by u square cos square theta. Is it clear? So this is regarding the object projectile motion and types of projectile motion, and the next equation of a trajectory. The next we have some definitions like what do you mean by instantaneous velocity? So what is instantaneous velocity in the projectile motion? As we know that in the projectile motion, the objects are moving in a vertical component. Okay, when it is moving in a vertical component, here what happens, that is vertical component of velocity changes, but horizontal component of velocity remains always constant. That is called as what? Instantaneous velocity. It is called as instantaneous velocity, right? So what is instantaneous velocity? During this projectile motion, here the objects will have two velocities. One is horizontal velocity and the other one is vertical velocity. If the vertical component of velocity changes, but the horizontal component of velocity remains constant, then it is called as instantaneous velocity. So for example, when a man jumps over the hurdle leaving behind its skateboard, then vertical component of his velocity is changing, but not the horizontal component, which matches with the skateboard velocity. As a result, the skateboard stays underneath him, allowing him to land on it. Means here, based on this example, we can draw one rough figure here. Here we can consider a man jumps on a hurdle. Okay, so he is wearing that skateboard. Here you can zoom this picture, that is, you can take like this. So here, this is one parabolic or a horizontal path. Here the hurdle is placed. Okay, means here this is there. The man is running from here. So when he is running from here, he will be wearing that skating board. So with the skating board, he will run, 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 run. And when he comes to this point, he will jump, and he will jump across this hurdle, and his skating wheel will pass through this. Right, this is what instantaneous velocity. So what they are saying here, when a man jumps, when a man jumps over the hurdle, leaving behind his skateboard. So skateboard he will leave and only he will jump. Then vertical component of his velocity is changing. So here you can see the vertical component of velocity is changing, but not the horizontal component, which matches with the skateboard velocity. So that is only what our instantaneous velocity, where only vertical component of velocity is changing, but horizontal component of velocity is remaining constant. As a result, the skateboard stays underneath him, allowing him to land on it. So you might have seen in the TV this example. Okay, so let vi be the instantaneous velocity of the particle at time t. Direction of this velocity is along the tangent to the trajectory at point p. Right, so that is, the velocity is given by, it is vi is equal to vx into I plus vy into j. So what is this vxi vy This is nothing but ij k are what? It is the unit vector along x and y direction. I and j are the unit vector along x and y direction. That is, vi is equal to vxi plus vyj, which implies, so if you find the resultant is given by vi is equal to vx square plus vy square, that is equal to, so substitute vx and vy. Vx and vy are what? It is the velocity component along x and y direction. So for x direction, it is given by u cos theta. So v square is what? U square cos square theta plus vy. Vy is what? It is u sin theta minus gt whole square. Right. So this second term, it is in the form of a minus b whole square. You can substitute the formula like a square plus b square minus 2ab. So after substituting and simplification, you can take out u square common here. So if you want to one step, I'll write here. That is, see what we can do. We can take it like that is equal to, it is u square cos square theta plus, inside the bracket, it is u square sin square theta plus g square t square minus 2u sin theta into gt. This is inside the bracket, we are getting it, and this everything is under root here. Again, this is everything is under root again. So this is u square cos square theta plus u square sin square theta plus g square t square, plus into minus is minus, same term as it is. Now you can see in these two terms, in the first two term, you can take out u square common. Inside the bracket, you are left with what? U square cos square theta plus sin square theta. So what is sin square theta plus cos square theta? It is 1. Therefore, it becomes under root of u square plus g square t square minus 2u gt sin theta. So this is under root here. This is under root, the value is written. So this is what the resultant velocity. This is the resultant velocity. Then the direction of the velocity is given by tan alpha is equal to Vx divided by Vy. So what is Vx value? Vx value is u sine theta minus gt divided by, that is Vy value, and Vx value is, it is divided by u cos theta, or alpha is equal to, we can write tan inverse of tan theta minus gt by u into sec theta. Okay, so it is tan inverse of tan theta minus gt by u into sec theta is what? It is angle. First one is direction, that is tan alpha is equal to, then alpha is equal to what? It is tan inverse of the given value. This is regarding the instantaneous velocity. Then what do you mean by change in velocity? What do you mean by change in velocity here? So change in velocity is nothing but what? It is initial velocity and final velocity subtraction. Therefore, change in velocity, initial velocity at projectile point ui is equal to u cos theta into I plus u sin theta into j. So final velocity is equal to uf is equal to u cos theta into I plus 0 into j. So why it is written as 0? As it is at the final point. Okay, at the highest point, therefore the velocity at the highest point becomes 0. Therefore, it is written as uf is equal to u cos theta into I cap plus 0 into j cap. Change in velocity in bracket, it is between projectile point and the highest point, that is given by uf minus ui. So what is uf minus ui? It is nothing but minus u sin theta into j cap. Okay, when body reaches the ground after completing its motion, then final velocity is equal to u cos theta into I cap plus u sin theta into j cap. So this is the expression for what? Final velocity. Okay, so it is expression for final velocity. Right? Let us see the next point. So next point is what? That is change in velocity between complete projectile motion, that is delta u is equal to, so that is delta u is equal to uf minus ui. That is, already we have seen that it is minus 2 ui sin theta into I cap. Right? Then next is angular momentum. So what is angular momentum? So angular momentum we know already. It is nothing but the product of momentum and the perpendicular distance is called as angular momentum. Let us see in case of it. Motion in a plane, what is the definition? So angular momentum of projectile at highest point of trajectory about the point of projection is given by. So it is given by, you can see the expression, L is equal to mv into R is what? It is the expression for angular momentum. So here R is equal to H is equal to 2u sine square theta divided by 2g. Here the value of H is written, that is height, expression for height, it is written 2u sine square theta divided by 2g. Therefore, it is L is equal to mu cos theta into u square sine square theta divided by 2g, that is equal to next. L is equal to, it is mu cos theta into bracket u square sine square theta divided by 2g, which is equal to mu cube in simplification of the previous term. That is mu cos theta into u square sine square theta divided by 2g, that is equal to mu square cos square theta into sine square theta divided by to g. That is the expression for angular momentum. Okay. Then next we have time of flight. So what is time of flight here? The total time taken by the projectile to go up and down to the same level from which it was projected is called as what? Time of flight. So time of flight is nothing but what? It is the total time taken by the projectile to go up and to go down. Go down means it is traveling the same from, means it will go up first, then it will come back to the same point. So here whatever the time it is taking, it is called as what? Time of flight. For vertical upward motion, the equation is what? We have the equation as what? Y is equal to u sine theta minus gt. Therefore, t is equal to, we are writing it as t is equal to, it is u sine theta by g. Okay, so here what happens, as it is going down and going up. So therefore, we need to calculate the total time here. As it is first going up, then it is taken as, then the time is taken as time of ascent, and then the time when it is coming down, the time is taken as time of descent. So time of ascent is 2 u sine theta by g, and time of descent is again it is u sine theta by g. Then if you combine, you will get it as 2u sine theta divided by g. 2u sine theta divided by g is the expression for what? Time of flight. Is it clear? Next, time of flight can also be expressed as t is equal to 2uy divided by g. It can also be written as what? 2uy divided by g, where uy is what? Vertical component of initial velocity. Ui is the initial component of, vertical component of initial velocity. Okay. So if in the question, consider the complementary angles, if it is given like that, then what we can do here, we can take one as theta and the other one as 90 minus theta. That is called as what? Complementary angles. Okay, such type of questions we have in the MCQs. Let us discuss that also. The next point, that is the ratio of time of flight. So here, whatever the sums you are seeing, that is time of flight is given by 2u sine theta by g. Similarly, ratio of time of flight is given by t1 divided by t2. It is given as t1 divided by t2, where t1 is what? 2u sine theta by g, and t2 is what? 2u sine of 90 minus theta by g. Why it is 90 minus theta? Because whatever the ratio of time of flight I am taking here, one is for angle and the other means here complementary angles it is. So therefore we take it as theta and 90 minus theta. So sine 90 minus theta is what? It is cos theta. Therefore 2u will get cancelled, then g will get cancelled. Therefore finally you are getting it as tan theta. Why? Sine theta divided by cos theta is what? It is tan theta. That is t1 divided by t2. Then next, multiplication of time of flight. So multiplication of time of flight is given by, it is 2u sine theta divided by g into 2u sine theta divided by g is equal to. So if you simplify this, you will get it as what? Actually, you will get it as 4u square sine square theta into cos square theta by g square. But means if you multiply here what they have did, here the value of whatever u square sine square theta into cos square theta is there, that is nothing but what? It is the r value. R is nothing but here it is the horizontal range formula. Therefore it becomes 2r divided by g. Okay, if t1 is the time taken by projectile to raise up to point P and t2 is the time taken in falling from point P to ground level, then t1 plus t2 is equal to what? It is 2u sine theta divided by g. It is 2u sine theta divided by g here. That is for what? That is the time of flight equation. 2u sine theta divided by g is the expression for sine theta. The next, that is, if t1 is the time taken by projectile to rise up to point P and t2 is the time taken in falling from point P to ground level, then T1 plus T2 is equal to, it is 2u sine theta divided by g. It is what? Time of flight. Or we can also write it as u sine theta is equal to g into bracket T1 plus T2 divided by 2, and height of the point P is given by h is equal to u sine theta T1 minus half g T1 square. Therefore, h is equal to, it becomes g into bracket T1 plus T2 divided by 2, and height of the point P is given by h is equal to u sine theta into T1 minus half g T1 square, that is equal to g into bracket T1 plus T2 divided by 2 minus half g T1 square. So by solving h is equal to, we will get h is equal to, it as g T1 T2 divided by 2, right? So how we got it for time of flight T1, here for h also we have it as g T1 T2 divided by 2. Okay, if B and C are the same level on trajectory and the time difference between these 2 points is T1, similarly A and D are the same point on the graph at time T2, then T2 square minus T1 square is given by 8h divided by G. Means in the figure you can see that A, B, C, D. Okay, so that is 2 position. Its time is given by what? T2 square minus T1 square is equal to 8h divided by G is the expression. Okay, the next. So horizontal range formula. Horizontal range, it is the horizontal distance traveled by the body during the projectile motion. So by using the second equation, of motion, that is given by r is equal to u cos theta into t. U cos theta into t value already we know, t is given by 2u sin theta divided by g, that is time of flight is equal to 2u sin theta divided by g. I have just substituted the value. So here what happens here, that is 2 sin theta into cos theta is nothing but what? Sin 2 theta. U into u, it becomes u square sin 2 theta divided by g is the expression for r, that is horizontal range. Okay. Next, range of projectile can also be expressed as, we can also express this range as r is equal to u cos theta into t. So u cos theta into t is what? It is 2u sin theta divided by g. This can also be written as 2 into u cos theta is written as ux, u sin theta is written as what? Uy divided by g. That is equal to 2ux uy divided by g is the expression for range of a projectile. So where ux and uy are the horizontal and vertical component of initial velocity. If angle of projection is changed from theta is equal to theta dash is equal to 90 minus theta, then range remains unchanged. Then the range remains unchanged here. Okay. So what they have said, if the angle changes from theta to theta dash, then the range remains unchanged. Okay. Next. Maximum height. So maximum height, it is nothing but it is the maximum height from the projectile. Okay. From the point of projection, a projectile can reach. It is the point up to which the particle can reach during the projectile motion. That is called as maximum height. Okay, so by using the equation, that is v square is equal to u square plus 2as, we can solve h is equal to, that is final velocity will be 0, that is 0 is equal to u sine theta whole square minus 2 into g into h. So u sine theta whole square, how to write it? It becomes u square sine square theta divided by 2g, that is equal to h. H is equal to, it is u square sine square theta divided by 2g is the expression for maximum height. Next, maximum height can also be expressed as h is equal to uy square divided by 2g, where ui is the vertical component of initial velocity. Ui is the initial component of vertical component of initial velocity. Okay, so h max is equal to u square divided by 2g, where sine square theta is equal to maximum when theta is equal to 90 degree. When sine square theta is maximum when theta is equal to 90 degrees. So in some of the multiple choice questions, they will be given that when the maximum height is maximum, when the maximum height value is maximum, that is theta is equal to 90 degree. That is, for maximum height, body should be projected vertically upward. So it falls back to the point of projection after reaching the maximum height. So for complementary angles, what is complementary angles? We know that complementary angles are theta and 90 minus theta. Therefore, the ratio of maximum height can be written as h1 divided by h2. h1 is given by u square sine square theta divided by 2g whole divided by u square sine square. In place of theta, we are substituting 90 minus theta whole divided by g. So if you simplify this, what you will get? Sine square 90, sine square 90 minus theta is what? Cos square theta. So 2g will get cancelled, u square will get cancelled. Therefore, you are getting it as what? Sine square theta divided by cos square theta is equal to tan square theta. So h1 by h2 is equal to, we are getting it as what? Tan square theta. So in multiple choice questions, you may get this type of question also. The ratio of maximum height is given by, it is tan square theta. It is tan square theta. Okay. Next, projectile passing through two different points on same height at time t1 and t2. So if the particle passes 2 points situated at equal height, that is y at t is equal to t1 and t is equal to t2, then that is given by, see here, that is height y is equal to, it is u sine theta into t1 minus half g t1 square. Okay, that is equation 1. That is equation 1. Next, y is equal to, we can write it as u sine theta into t2 minus half g t2 square. Comparing equation 1 and equation 2, we will get it as, if we compare equation 1 and equation 2, we will get it as u sine theta is equal to g into bracket t1 plus t2 divided by 2. So by substituting this value in equation 1, we will get it as y is equal to g into bracket t1 plus t2 divided by 2. Okay, so y is equal to, it is g into bracket t1 plus t2 divided by 2 into t1 minus half g t1 square. So this implies y is equal to, it is g t1 t2 divided by 2, right? See here, this is what the height equation, when the projectile is passing through two different points at the same height and time t1 and t2. So now y is equal to, we have u sine theta into t minus half gt square. Therefore, we will get it as, if we simplify this, so just see the final equation, t1 is equal to, and remember the formula, t1 is equal to, it is u sine theta by g into bracket 1 plus root of 1 minus root of 2gy divided by u sine theta whole square. So you know theta is angle, g is acceleration due to gravity, y is displacement or distance, then u is initial velocity. The terms carry its usual meaning. Then t2 can be written as, it is u sine theta divided by g, okay, into bracket 1 minus root of 1 minus root of g 2gy by u sine theta whole square. So what is the difference between T1 and T2 equation? T1 is 1 plus root of, T2 is 1 minus root of. Next we have energy of a projectile. So what is energy of a projectile? Energy of a projectile is nothing but it is the total energy possessed by during the projectile motion. Okay, so that is called as what? Projectile energy or energy of a projectile. See that. what it is given. That is, energy of a projectile is nothing but, it is the, when a projectile moves upward, its kinetic energy decreases, potential energy increases, but the total energy always remains constant. But the total energy always remains constant. If a body is projected with initial velocity, with the initial kinetic energy, that is half k mu square, with angle of projection theta with the horizontal, then at the highest point of trajectory, at the highest point of trajectory, kinetic energy is equal to, it is given by half m u square. So here the component is u cos theta, therefore it becomes half m into bracket u cos theta whole square, that is equal to 1 by 2 m u square into cos square theta, that is equal to k dash is equal to k cos square theta. So k is what? Half m u square. K is what? Half m u square, right? See that next. Potential energy is given by what? It is mgh. Potential energy is given by mgh, which is equal to mg into h is u square sine square theta divided by 2g, which is equal to half mu square sine square theta. Why? Because h is equal to what? It is h is equal to u square sine square theta divided by 2g, right? H is equal to u square sine square theta divided by 2g. Okay. Next, total energy. So total energy is nothing but, as I told you, it is sum of kinetic energy and potential energy. So kinetic energy is given by half mu square cos square theta, and potential energy is given by half mu square sine square theta, that is equal to half mu square. Why? Because half mu square is common. Inside the bracket, you are left with sine square theta into cos square theta. Okay. Therefore, we will get it as sine square theta plus cos square theta as 1. It is nothing but energy at the point of projection. Energy at the point of projection. This is the accordance with the law of conservation of energy. So what they say, it is the conservation of law of energy. What is the law of energy here? Conservation of energy. Energy neither be created nor be destroyed, can be transferred from one form to other form, right? Next, horizontal projectile. So what do you mean by horizontal projectile here? Horizontal projectile is nothing but a body be projected horizontally from a certain height y vertically above the ground with initial velocity u. If friction is considered to be absent, if friction is considered to be absent, then there is no other horizontal force which can affect the horizontal motion, which can affect the horizontal motion. The horizontal velocity is given by, see here, already we know what do you mean by oblique projectile. Oblique projectile is where the kinetic energy, the energy will change, but here the momentum and other quantities will remains constant. That is oblique projectile. Then next here, horizontal projectile is what? It is from certain height vertically above the ground with initial velocity u. If friction is considered to be absent, then there is no other horizontal forces acting on the body. That is for what? Horizontal projectile. Okay. Therefore, which remains, the velocity remains constant, and also, and so the object covers equal distance to in horizontal direction in equal interval of time, right? Next, trajectory of horizontal projectile. So what do you mean by trajectory of horizontal projectile? The equation for trajectory of a horizontal projectile is, just now we have seen for all the oblique projectile motion. Now we are seeing for trajectory of a horizontal projectile. It is given by the horizontal displacement x is governed by the equation x is equal to ut, which implies t is equal to, it is u divided by x. It is u divided by x, that is equation 1. Okay. Next, vertical displacement is given by, it is 1 by 2 half gt square. That is equation 2. Since initial vertical velocity is 0, by substituting the value of t in equation 2. So what is that expression? Substitute the value of equation 1 in 2. Therefore, we will get it as y is equal to half gx square divided by u square. Half gx square divided by u square. Okay. Displacement of projectile. So what is the expression for displacement of a projectile? Let us see that. After time t, horizontal displacement x is equal to ut and vertical displacement is given by y is equal to half gt square. So the position vector r is equal to, we can write it as ut into I minus gt square into j cap, where I and j cap are what? Unit vector along x and y axis. Okay. Therefore, we have r is equal to, expression is r is equal to ut root of 1 plus gt divided by 2u whole square, and alpha is equal to tan inverse of gt divided by 2u. Tan inverse of gt divided by 2u is the expression for alpha. Right. So this is what displacement of a projectile. Next. Therefore, the previous equation, that is alpha is equal to tan inverse of gt by 2u, can also be written as alpha is equal to tan inverse of, substitute the value here, it becomes under root of gy by 2 divided by 2u, where t is equal to what? It is root of 2y divided by g. Root of 2y divided by g is the expression. So students, in this chapter, we need to remember maximum formulas to understand the concept. Okay. So formulas only help us to calculate the given question. Projectile motion on an inclined plane. So here in the picture, you can see the inclined motion of a projectile. Okay, it is making some angle alpha with x-axis. Right. Let a particle be projected up with a speed u from an inclined plane, which makes an angle alpha with horizontal velocity of projection, makes an angle theta with the inclined plane. Okay, so in the figure you can see whatever the explanation it is given. Hence, the component of initial velocity parallel and perpendicular to the plane are equal to u cos theta and u sin theta. The velocity is equal to what? U cos theta and u sin theta respectively. Right. Therefore, u parallel is equal to u cos theta, and for perpendicular component, that is equal to u sin theta. Right. The component of g along the plane is g sin alpha, and perpendicular to the plane is g cos alpha, as shown in the figure. Okay. Therefore, a parallel is equal to minus g sin alpha, and g perpendicular is equal to, what is equal to what? That is g cos alpha. So parallel and perpendicular components are written. Next. Therefore, the particle deaccelerates at a rate of g sin alpha as it moves from O to P. So in the figure, you can see when it is moving from O to P, it will deaccelerate. Okay. Next, time of flight. So already we know what is time of flight, time of ascent and time of descent. Okay, so that is given by time of flight is equal to, it is the oblique projectile motion, t is equal to 2u sine theta divided by g, or it is given by t is equal to 2u perpendicular divided by acceleration perpendicular, right? This is how we can write the expression for time of flight for a horizontal motion. Next, that is maximum height. The maximum height h is equal to, it is u square sine square theta divided by 2g, that is equal to h is equal to u square divided by 2a. So same formula we have in case of horizontal and oblique motion, and here it is given by, for an inclined plane, it is h is equal to u square sine square theta divided by 2g cos alpha. So horizontal range is given by what? That is s is equal to ut plus half at square, that is equal to r is equal to u parallel t plus half a parallel t square. Therefore, r is equal to u cos theta into t minus half g sin alpha t square. So you can write the value of t here, that is 2u sin theta divided by g cos alpha minus half g sin alpha into bracket 2u sin theta divided by g cos alpha whole square. By solving, r is equal to 2u square by g and sin theta into cos of theta plus alpha divided by cos square alpha, right? So this is how we can write the expression. So students, today in the class we have discussed about what do you mean by projectile, what do you mean by projectile motion, what are the types of projectile motion, in that the related terms like, that is time of flight, horizontal range, maximum height, these all terms we have defined and discussed the formulas for that. Okay, so in the next class, let us continue with the circular motion and the expression for circular motion. Okay, thank you.